Hello and welcome to Database Management Systems. I'm Jivita Christie, and in this video, I'm going to introduce you to two more formal query languages like relational algebra. One is known as the tuple relational calculus, and the second one is the domain relational calculus. So let's begin with the tuple relational calculus. This is a query language just like relational algebra, but it is non-procedural. So relational algebra is a query language that is procedural because you specify which operation to perform first, whether to do a sigma, whether to do a pi first, or to do a Cartesian product or a natural join, because you are specifying lots of brackets everywhere. And due to that, you can tell which operation to do first. So relational algebra is procedural, but the tuple relational calculus is non-procedural, just like SQL. But it is a formal query language, which means it's not necessarily implemented, but you can get a very good idea of how an actual language would work, like SQL, if you study tuple relational calculus. Normally, if you have studied relational algebra, there wouldn't be a requirement for you to study tuple and domain relational calculus, but it's just an introduction. So if you would just like to know how notation is different and how queries are written in this, then this is a great start for that. So it is non-procedural, meaning it does not specify the procedure. It simply tells you what to get. It does not tell you how to get that. Just like SQL does, where you write down just select star from some table, and you don't specify any instructions about how to get that data. So this is the same, and in tuple relational calculus, a query looks something like this. You can see there is in curly braces, we are writing down T, and then we are writing PT. Here, T stands for set of tuples such that P is true for that T. So that's what this example looks like. So T is a set of tuples. Tuples in a table or a relation are all the rows. So this calculus, this language works on the basis of different rows. So T stands for those rows, and P is a predicate, which is true for T, and that's why we write PT. And we use T with box brackets A to denote the value of tuple T on attribute A. So A is an attribute, and we show it in box brackets. And we also use T belongs to R to denote that the tuple T is in relation R. So if you write T belongs to R, R would be the relation in which the tuple T is present. Now for knowing this better, I would recommend an example. So let us see an example of such a query. Consider this table. This is an instructor table which contains details of several instructors, their IDs and names and their department names and their salaries. And this is also a table that I have used in many videos, previous ones and even forthcoming videos, because I'll be even in relational algebra, because this is relational calculus is just like relational algebra. And so if we use the same relations, you will be able to correlate the two better. So now this is the table which contains the IDs of different instructors. It contains the names of different instructors and which departments they belong to, as well as their salaries. Now the query that we are going to answer is to find the ID, name, and depth name and salary for all instructors whose salary is greater than $80,000. So it's a fairly simple query, and if you were using a relational algebra, then you would just be using the pi operation, and using the pi operation, you just write down ID, name, dep name, and salary, and then use a sigma operation to write down sigma salary greater than 80,000 and put instructor relation in a bracket. So I'm sure if you've reached this video by watching the videos on relational algebra, then you are well aware of how that works. Now for this video, we are going to do this in the form of a tuple relational query, which looks like this. So what you have here is T, which is right here. So this is T, and T is a tuple once again. So we are talking about all the rows of this table. And this pipe over here means such that. So T such that T belongs to instructor, because we are talking about only rows from the instructor relation, not some other relations. T belongs to instructor. And this symbol right here you're familiar with because we were using it in relational algebra. This symbol means and. So T belongs to instructor and T, and then in box brackets, salary, which means we are talking about the salary attribute of T. And then we are putting the condition that this is greater than 80,000. Notice that there is no mention of columns in this because this is a tuple relational calculus. It does not work on the basis of columns, and plus we are actually trying to get all the columns. There are 4 columns and we are trying to get all 4. So how exactly does this work? It works on the basis of a tuple. So if we consider the first row is T, and of course T belongs to instructor. And like we saw in the previous slide, we saw that the structure of this query is T and then pipe and PT, where P stands for predicate that is true for T. So here T belongs to instructor is true. This part is true because T is something I've taken from instructor. And the second part is also is something that needs to be checked. So T of salary, which means for the first row, what is the salary? The salary is 65,000, which is not greater than 80,000. And so the first row is discarded. But what about the second row? The next time this is applied on the second row, and T is equal to this second row. And once again, the first condition is satisfied because T does belong to instructor. But and also the second condition which is there, which is T of salary greater than 80,000, is also satisfied because the salary is 90,000. So the second row is produced in the result. And similarly, this row with Einstein is produced in the result. The row with gold and physics is produced in the result. And the row with Brandt and computer science is produced in the result. So this is a very simple example of a tuple relational calculus query. Now let's proceed to domain relational calculus. Domain relational calculus works with domain variables. So in tuple relational calculus, we were working with rows and using rows as variables. In domain relational calculus, we will be working with columns and using column names as variables. But it is very much like tuple relational, and it is non-procedural as well. Now, this is what a query looks like in domain relational calculus. We have a set x1, x2, and so on, which represent domain variables. So your column names will go there. And then we have a pipe here, and this is P, which represents a formula, just like it represented in tuple relational calculus. It's a predicate that represents formula. Let's see an example. Once again, we will use the same instructor table with these 4 rows: ID, name, department name, and salary. And this is what we are going to answer. Find the instructor ID, name, dep name, and salary for instructors whose salary is greater than $80,000. So it's the same query that we did earlier with tuple relational calculus. This time we are going to do it using the domain relational calculus, so you can notice the difference between the two. And while you're doing that, you might also want to notice the difference between these and relational algebra. So this is what it looks like. Now, we do not need to write the domain names as they are present here because we are using variables. So instead of ID, I'm just writing I. Instead of name, it's just N. Instead of depth name, it is D. And instead of salary, it is just S. So you don't have to specify the whole name of the column because these are just variables that represent the columns. They are not actual columns. So this is the value given here. And then there's a pipe, so such that INDS, they all belong to instructor, just like we did in tuple relational calculus. So this is the first condition. And the second condition is that S should be greater than 80,000 because S is something we are associating with the salary of instructor. So INDS is the combination of columns that we want, and the first condition of this to be successful for a row to be executed is that this should belong to instructor. So if we are talking about name, any name in N, then that name in N should belong to the instructor table, and for that name the salary associated with it, which is S, should be greater than 80,000. So that's a simple query. Let's do another one for clarity. So this is another example. Find all instructor IDs for instructors whose salary is greater than $80,000. So this time we are not talking about finding everything: ID, name, depth name, and salary. We are talking about finding only the instructor ID for salary greater than 80,000. So this is how you would write this query. Because you want only name to be displayed, you will be writing just N before the pipe. After the pipe, you're writing there exists IDS. Now, IDS are there because IDS are not to be displayed. So they are shown inside. So there exists IDS. And then in bracket, you'll mention that all four INDS, they belong to instructor, which is necessary, and also that the salary should be greater than 80,000. So when you don't want to include IDS in your result, then you would show them after the pipe in this manner. This is another domain relational calculus query. And that's it for relational algebra. That's it for all the formal languages that you can study in DBMS. And also I'm going to conclude this video and I'll see you in the next one. Thank you for watching.